Good evening, everybody. I'm Prerna from Cognixia and I represent the enterprise team here. On behalf of the team, I welcome everybody who is present for the session today. I hope all of you are doing well and safe at your places. We will be having a session, a detailed session on Apache Spark today, as you would already know about it. So before handing over the podium to our speaker, I will take about a minute or so to introduce about Cognitia because some of you may be attending the session for the first time. So Cognitia happens to be world's leading digital talent transformation company. There are various things that we do to transform the talent of various organizations, right from training them to certifying them and lot many more. We have trained over 1,35,30,000 professionals worldwide. We have also been delivering to 45 countries over the globe. We work with over 7,000 industry veterans who are our consultants, speakers, and trainers for various engagements that we do with our clientele here. And we also cater to 450 plus customers all over the globe. We are authorized training partners with Red Hat, Automation Anywhere, ITIL, ISC Square, and we're also silver partner with Microsoft. So in case you, your team, your colleagues, anyone, if they need a certified training on any of these, we can directly help you here with the same requirement. We also have a lot of awards and recognitions by our side. Some of those are listed on the slide that's in front of your screens. Moving ahead, we have certain centers of excellence. Like I mentioned, we help various corporates to undergo certain trainings and transformation of the workforce. So these are certain areas that we specialize into. We have a great expertise upon machine learning and artificial intelligence, also courses like RPA, microservices, Internet of Things, big data, DevOps, cloud, and many more. I'm sure you would agree that these are the need of the hour and are definitely hotcakes in market. Anyone who is skilled under these technologies would be having great things on their plate already. So yes, this is something that we can always help you with in detail, and this can be discussed as well if the need be. Moving on to the next slide. Because there is the sudden outbreak of COVID-19, and we really had to help our customers keep going with the learning plans and strategies that they had for the year for their employees, we have come up with various modes to help them engage with the audience there. We came up with an idea of master classes that happen to be 1 day extensive on hands-on sessions. These are also, attached with a certification at the end, towards the end. And the speakers, the instructors for these sessions are industry veterans and very, very senior folks from the industry. Also, flashing in front of you is the little schedule about it. We have 2 sessions upcoming on this Saturday. We are already on a Wednesday. 25th April is when we will have 2 sessions parallelly running, one of which will be on machine learning in production, as you can see on your screens. Second would be on Docker and Kubernetes. So in case any of you is interested, or you know someone who will find these kind of sessions useful and would want to enroll in these, you can refer them to us and write to webinar@cognitia.com, or you can simply drop in a note towards the end of the session and we should be able to get in touch with you or them directly. More sessions are listed in the table about Azure IoT, React.js, and AWS that we plan to come up with. Similarly, we have full-fledged training that we can support you with. These are live instructor-led virtual classes, or the VILTs as we call them. No one's having classroom trainings for now, so virtual sessions are the only way to go ahead and support the teams to have the learnings in progress. So data science, machine learning, AWS, Azure, Python, Spring Boot microservices, and ITILs are certain courses that we can help you with. These happen over the weekends. So they will not hamper your work at all. Plus, you will have great time to invest in your self-learning. If you need any more details, you can anytime drop a query to us, either to our website, to our email addresses, or at the end of the survey forms that you'll receive. With that, I think we are good to begin with the session. I have a quick request to make in case you are not able to listen to the audio clearly, or you are not able to access to the video properly. We will request you to join one more time. We'll request you to leave and join in again. Also, you can try switching to an area better connectivity at your places. Maybe that will help you. In case the problem still persists, we would apologize for that, and do not worry, as we will anyway be sharing the recording links with you, and you will have the access to the webinars anyway. Also, the certification to all the attendees towards the end of the session will be given. We will need some time. We'll request you time of at least a week to come back to you with the recording links along with the certifications for your use. Okay, I think we are good to begin the session now. So I'll hand over the podium to Navneeta, our speaker for today. Navneeta, welcome, and you can take up the session from here.
Thanks, Prina. Thanks, Prina, for the introduction. Hello, guys. So welcome to the session. So it's a very nice evening here, and we are going to see about the big data and its advancement. I mean, you guys are. I believe like you guys are pretty familiar with the term big data. Like right nowadays in the market, this is one of the a talk of the town, and we have a lot of different advancements which are coming on the big data. We are going to talk about how the big data has evolved and how it is evolving now, and what kind of focuses you have to keep on the career towards big data, which could help you to excel on career side. So we have few parts of the session. So I mean, the session got split into a few parts. So first we would be just understanding about the overview of traditional big data components. So what are the big data components contribute, which start, what are the big data components contributed to the traditional infrastructures, then how it got evolved to a different level, and how it got adopted by the cloud managed services. Then what is the necessity of a real-time data streaming platform, and the advancements in big data. What kind of other advancements which got, what kind of products are there, what kind of features are there with the product, what are the different integrations which are available, and how it is going to help to the developer community or the data science community or the data engineering community to make the work more ease with a lot of integrations. That's what we're going to see. Let's start with the chapter 1, traditional big data components. So there are, whenever we see a framework or a architecture, there would be a lot of basic architecture behind it. So we would be understanding the case for it, and also we'll be just seeing the term of how this architecture helps us. So the why big data first? So the reason for big data is data are getting generated without bonds. Like earlier we were doing all the financial transactions by visiting the banks. We have a passbook and we do all things updated in the passbook, and we get our money transactions by visiting the bank. Similarly, you go to the specific shop to buy the cloths or some other material. So, but now it's all different. So we have adopted to a different way of purchase, different way of banking, different way of using certain business activities. Which means like the companies are transitioning their business from a normal driven to the data driven. So which means right now the data are getting created without bounds. The example is financial transactions. Whatever financial transactions we do, it goes through certain different events. Let's say you pay, if you are sending a transaction from one person to other person. There are a lot of events which happens in between. You have to log into the bank account, then you have to choose the dependency, payee or dependents whom you want to send. Then you have to initiate the transfer, you have to receive the OTP there, and then the acknowledgement should be there. The transaction should go to a UPI gateway or IMPS gateway or RTGS gateway or different gateways. Then from there, we have to wait for the time based upon their ETA. And once it is done, the account gets credited, then it gets notified. These are the process. So in this process, there are huge amount of data which are getting generated. So all the data points are more important for the business. For that enterprise, they have to capture all the transactions. By that way, they build trust with their customers. And maybe we can say like, okay, in a bank transaction, if one activity is not getting tracked properly, that's a big problem for the business. Similar way, we are getting more data due to sensor network. Nowadays we have a lot of automated monitoring systems which are capturing the data. Again, server logs, the companies which are maintaining very huge number of machines, they are capturing the server logs, and based upon the server logs, they can predict a machine which faced this kind of failure in the past or in the previous days. It got failed after 3 days. Consider a machine got a particular log issue on 13th April. I mean, it may supposed to get failed on 17th April as per their predictions period. So we can go and do a fix so that the systems or the servers would be highly available. And email and text messages, it's all because of us. We are doing a lot of message based transaction. Then we have social media, which is a ocean of data. And then machine feed. So data are getting generated without bounds on various different ways because of a lot of facilities we have right now on creating the data and transferring the data. Like data transfers are very huge. So, and we are generating data faster than ever because we have very good lot of automations are there in various different places, and we have very good internet connectivity. And as a user, we are not writing anything. We just typing the text and keeping the user generated contents. A lot of user generated contents. And we have IoTs which are generating more data nowadays, uh, which are helping us on home automation, industry 4.0 based automations, where most of the industries they are trying to automate or identify the wear and tear of machines using IoT. And also there are a lot of bots, like in few of the industries, instead of the operations which are which should be performed by humans are being replaced by bots. In that sense, like bots, what IoTs and bots are, if they want to respond, they have to generate a lot of data. So now we are in an era like all the business driven enterprises are generating very huge amount of data, and for them each and every data are most important because they would be getting value out of it. That's what we're going to see. So Twitter processes more than 500 plus million tweets per day. Facebook users generate 7 billion comments and likes. It's all because of us. And YouTube gets 30 million users per day. Maybe due to lockdown, it would have gone much. So 5 billion videos are watched in YouTube per day. Every minute, Amazon makes this much sales. 280K plus maybe. Now it would be lesser. Google gets 3.5 million search every minute because of, I believe like most of them are because of software engineers and so and other few technically involved people. I mean, system based and 400K new tweets every minute. So all for these companies, these are the most important data. They have to first identify a way to capture the data. They have to store the data. They have to process the data. They have to either store the data or they have to stream the data. They have to process the, I mean, they have to extract certain value when the data is flowing, which means they don't have time to wait for 2 minutes. Let's say you are doing a bank transaction, a malicious transaction is happening, or maybe you are doing a payment to a gateway which is being considered as a slightly illegal gateway. So if a bank is calling you within a minute and ask you for a verification, that's a real time. That could be a real time or near real time. So you get more trust on the bank. So those are the alert mechanism. So nowadays the data are generating on a very huge amount. We also have a lot of demands on processing the data, which could be batch based, which means you can collect the data at a point, you keep it for 30 minutes or half a day, then after that you can process the data, which means the data the ETA is there for the process, and it's not high, it's not on a high demand. And we have micro batches, which means the data could be processed within 10 minutes. You need some results. So and also we have real time, which means there are some seconds or millisecond based time. So you have to do a processing within the time. Consider you are sending a UPI transaction, and if your friend at the other end is not receiving the money within few seconds or few minutes, you may question the company which is doing the transaction. So that, which means like there are something which needs to happen within millisecond, so you get a response within second. So a lot of requirements are there for the real-time data, and the businesses are keen on getting the insights out of the real-time data. So we'll see that. So with all those data, we can do marketing analysis when we can find like, okay, what's going to be the market trend, how I'm going to get affected because of this factor. And product recommendations. The e-commerce companies can say a person like your buying pattern also bought this, so they can provide recommendations. And demand forecasting. Okay, maybe as a seller, I'm selling a sweater or I'm selling a woolen cloth. So it can give me a forecast like, okay, during this climate, the woolen cloth would be, I mean, the demand for woolen cloth would be more in this region. So something like that. And fraud detection. Maybe in e-commerce, certain buyers would buy more product from me, and within few days they would return back. Or certain specific pattern of buyers we can identify, and we can have more fraud detection methodologies toward them. And predictive models. Okay, with this with all the data, we can do a lot of insights out of it, and which could help the business to run more stable and more the customers would get more trust out of it. So now we are seeing like the data are getting generated in a massive amount, and we have to do a lot of process. The process could be we need to have a real-time alerting mechanisms. We need to process the data, and we have to get insights out of it. So that would help the business. In those scenarios, what are the most important thing which are in need? So we are getting very huge amount of data. Yes, we need to store the data. So it's not just consider I am a onion seller or onion dealer. I get 10,000 tons of onion every week. So if I just store my onion, it would not be helpful for me. So I have to send the onions to the market or to the next level agents. So first of all, I'm getting 10,000 tons of onions. I cannot keep it in a single warehouse. I mean, I have to split it and store it. Then I have to send it through containers or some other vehicles. So that's what we are going to see. We have two different problems: large scale data storage and large scale data analysis. Here we are going to get very huge amount of data. So I cannot store the very huge amount of data as it is. So in the big data infrastructures, most of the big data infrastructures, the data would be distributed and stored, and also the data would be processed and distributed way. Consider an onion seller is getting 10,000 tons of onion. He store all 1,000 tons of onions on different rooms. Again, when you want to transfer the data, when you want to send the onion to different agents, he load it in the containers and he send it. So that's how the data storage and data access happens. So the huge amount of data will not be stored as a single data set. It will be sliced and it will be stored. So when you go through Hadoop architecture, you would come to know that. We are going to see overview of how it can be done. So this is where the traditional big data components play a vital role. So now we have traditional components like Hadoop. In Hadoop, we have two core components. Hadoop distributed file system. As I told, take the onion example. The onion seller is not going to store onion or 10,000 tons of onion as a single entity. He would be storing it in different multiple chunks. Similar way, you are getting a very huge amount of data. So we would in HDFS the data would be stored based upon few block size. So in HDFS the default we have a bigger file. The bigger file will be sliced, and this file will be stored on different clusters. So let's say you have we will be having a group of servers, and HDFS will formulate a file system on the group of servers. So HDFS provides a proper distributed file storage, and the next is we have right now we have a file which are distributed on HDFS. Okay, so now we have to process the data. So for processing data, there should be some framework which would provide a resource management. Let's say, okay, my process may require this many resources on these different machines. Okay, so containers or executors, we call in a technical term, we call it containers or executors on yarn. So this yarn will provide, consider again on the same scenario, the data are stored in multiple servers, and also on the same server the processing would happen. Okay, so in this scenario, yarn provides, okay, you for processing the data, server 1, which is a worker node, need 10 specific containers of 4 GB 2 week or 8 GB 2 week or 24 GB 4 week or something like that. The specific processing unit will be allocated on different machines, and then the execution engines will do the process. So there are two execution engines. So as of now, HDFS provides proper storage level architecture. Yarn provides resource management level architecture. So if the resources are given for processing, then the processing engines can work. So there are two type of processing engine: traditional disk-based MapReduce processing engine. Yes, it is disk-based because the data would be read from the disk, intermediate data would be written on the disk, and then the final result will be computed. So MapReduce is considered as slow, or maybe we can call MapReduce is highly suitable for batch-based processing. There we have one more processing engine or execution engine, we would say. It is Spark. So Spark is one of the hero of the big data right now. It's one of the talk of the town. A lot of companies are in requirement of Spark-based developers for the, like, if you are planning for a career on big data, so you must have this particular technology on your resume. So for this, you need to learn any one of the programming language, Python, Scala, or Java. So you have to be first of all prepare your prerequisite, I mean, which is a programming language. You can learn Python. I mean, if you're a Python developer, yeah, well and good. If you're a Scala developer, no worries. And if you're a Java developer, yes, still you can do all the Spark related things. So Spark provides in-memory based data processing framework. So the Spark, otherwise we call Spark as lightning speed data processing. So now we are getting huge amount of data. Those huge amount of data are getting stored in HDFS, and we have to process the data with the help of Yarn framework. The resources will be granted, and which are we have two different execution engines. One is a MapReduce based execution engine, which is highly focused on disk-based data processing. The other one is the Spark-based execution engine, which is highly focused on in-memory based data processing. So both of them can run on Yarn. So this is how we are going to store the huge amount of data, and we are going to process the huge amount of data. We also, in the traditional big data components, we also have a few other ecosystems. They are like Cassandra for a time series data model. Cassandra is one of the NoSQL component. We also have MongoDB, which is a document-based data store. The traditional infrastructure Kafka is one of the backbone for data ingestion platform. The enterprises which are mature the big data, you would see all the architectures which are there. They would be having a Hadoop infrastructure. Yes, for data ingestion, they would be using Kafka and Cassandra or Mongo or HBase in Hadoop. We have for data store for data lake or data hot data lake infrastructures. And the next one is Storm for stream processing. Storm is one of the oldest architecture for stream processing. We have few other stream processing. Some of the stream processings are now added in Kafka. We also have other few stream processing components. We would be seeing that. So this components forms the traditional big data infrastructure. So the companies which are following the big data in practices long time, let's say since 2014 or 2015. So they have started their big data infrastructure with most of these components. And yeah, of course, big data, the methodologies of big data and the architectures are getting evolved. A lot of advancements are coming, a lot of utilities are coming. So we'll see about it. So in the traditional big data based infrastructure, we have a Hive, which was created by Facebook for data, which is one of the Apache component. Is used for data warehousing and data analysis. Consider the data are stored in MapReduce and data are stored in HDFS, would be processed by MapReduce or Spark. You have to write a MapReduce or Spark program. In Hive, what we can do is we can write a SQL query. So the SQL query will be automatically converted to the MapReduce job or Hive Spark job. We also have one more component called Scoop, which is Hive. With whichever company using big data, they would be having Hive. And the next most important is Scoop. Scoop is used for moving data between RDBMS and Hadoop. We can import data from RDBMS to Hadoop infrastructure. We can export from Hadoop to RDBMS. So for those data movement, we have Scoop. Scoop, by the name itself, it means SQL, SQ for SQL, and OOP for Hadoop. Scoop. We have one more component introduced by Cloudera, which is Impala for interactive queries. So the queries execution engines are slightly different. It works on C++ based execution engine. Test and LLAP are different execution engines which are created by Hortonworks for repetitive queries. So the LLAP engine will keep the process data. Let's say you're running a specific query multiple number of times. The query results can be cached and it can be provided for the next set of queries. We also have HBase for columnar storage, and HBase would be used for the random access data, because in HDFS we can only have a streaming data. The data cannot be accessed on a random read and write. So for random read and write, the HBase is the only data store which provides it. and we have Woozy for workflow and many other components. Right now, we have a few other workflow-based components which are getting high interactions with Hadoop. They are Airflow and other few. So Woozy, these are the traditional components. So the traditional big data infrastructure comprises of all those things. Let's say Hadoop and Yarn, Hadoop HDFS for data storage, Yarn for resource management. With the help of Yarn, MapReduce and Spark execution engines will work. And then we have Hive for SQL-based data processing, Scoop to import data from RDBMS to Hadoop. Impala is also a SQL-based one, so Impala Hive and Hive can work together. Tez LLAP and Hive can work together. So Impala provides addition queries, or maybe I would say like the processing time would be slightly less because of the different execution engine. Tez and LLAP is highly suitable for repetitive queries. We also have Headspace, which stores the data on a columnar format, and then the data or the data model of Headspace would help us to have random access, random read and write. And finally, Woozy for workflow management. So this is how a traditional infrastructure has been established, and many of the enterprises are following this architecture since 2014, 2015 in a very mature way. So we are going to see how, again, we will be seeing which are companies or which are the enterprises providing solutions for this kind of traditional infrastructure. So right now we have earlier there were two big competitors, Cloudera and Hortonworks. Now both of them merged as a single entity. So Cloudera provides a platform called Cloudera Data Platform, which is right now available in the market with all these traditional components. And Cloudera is also having another package called CDH, which is now integrated with Hortonworks and became CDP. Hortonworks also have a product called HDP. You can still use this CDH and HDP, or you can go with CDP. There is other distribution of Hadoop which has been used by a few companies, are MapR. Again, from Hortonworks and Cloudera, there is a product called CDF and HDF, Cloudera Data Flow or Hortonworks Data Flow, for components which would help us on data ingestions. Consider we will see about the data ingestion components like Kafka, Flink, NiFi, and all those. I mean, the components of the components like Kafka, Flink, NiFi, Storm. All of them are added in a separate package called CDF. For Cassandra, there is a company which provides a package. We can also install all of them in Apache as an Apache component. But what happened is the management. Let's say if you want to manage the cluster, it would be slightly tough because you need to have more Linux administrators and Hadoop administrators to help you with it. But all the providers like Cloudera, Hortonworks, MapR, DataStax for Cassandra, and Confluent for Kafka, they provide better package, and also they have specific steps to install it, and they all of them provides a manager component. Let's say in Cloudera, the manager component is called as Cloudera Manager. Hortonworks, it's Ambari, and DataStax, they have control center. So Confluent, they have control center. So these UI, they have a web UI based cluster management component, which would help us to monitor the cluster. Like, let's say how many nodes are there in the cluster, and is there any error which are getting from a different cluster. So those will be aggregated in a single view. And do we need to do any configuration changes, or do we have to update certain, let's say due to one configuration change, we may have to restart certain machines, certain servers or certain processes. So how do we do it? We cannot go to every single servers and do it. This particular manager components can help us on restarting the specific processes or servers for our proper administration. So that's why the companies prefer the packages from Cloudera or Hortonworks or DataStax and Confluent for their big data infrastructure. So these are we have few other products also available on a traditional big data based upon the traditional big data components. And nowadays, as you know, we have a lot of cloud-based managed services, and we have other few architectures are there. We will see about that. But these are the traditional infrastructures. The companies, as I mentioned, Cloudera and Hortonworks, they merged and they are now single entity. So Cloudera provides CDP. Cloudera and Hortonworks provide CDP. Now they were also having CDH, HDP. MapR is having a Hadoop distribution. Cloudera is also providing CDF. They are also providing one more product called Cloudera Data Science Workbench for data scientists to create the model and deploy it. For Cassandra, DataStax is a company which provides packages. So Confluent, Kafka provides, they provide Kafka as a service. And we also have a few other cloud-based companies, especially we will see about in the evolution side, we will see about how Databricks is helping the developer community to run Spark, how AWS is providing managed services, what are the other managed services provided by Azure and Google Cloud. We will see about it. So traditional big data infrastructure can be deployed on on-premises based servers and also cloud servers. So consider let's say a company which is having which they want to set up a big data infrastructure, so they would need to have separate type of machines for master nodes and worker nodes. They have to consider, okay, let's say worker node, I need to have 256 GB of RAM, or with the system should have 16 to 24 cores, and every disk should be having two terabytes to 3-4 terabytes of disk and multiple number of disks. A server should have 15 disks, so comprises of 30 terabytes to 36 terabytes overall storage. There are a lot of considerations we have to do when we set up a Hadoop cluster. So I would say like the baseline Hadoop infrastructure would have 128 GB of worker node, which would have 16 cores or 20 terabytes of data. A midline will have 256 GB of RAM on every worker nodes. High end would have 512 GB, and also nowadays I'm seeing some of the cluster with 784 GB RAM. So those are the highly powered clusters which would run a very huge workload. And also from the cloud providers like Amazon, AWS, and Azure, we can take the cloud cloud VMs. Consider Amazon provides EC2 based Linux machines, and in Azure virtual machines can be taken. We can also set up Hadoop infrastructure on the cloud environment. So it depends upon the company's architectural decision. So enterprise need to set up a proper security. If they are doing that, they need to have a proper administration to manage the traditional components, because every service will have a factor called mean time between failures, which means every servers are likely to be failed within a specific bound. Let's say 2 years. In 2 years, at least some major problem would happen in a server. It's like something like how humans get attracted to fever or something. So every server, because in setting up this kind of infrastructure, we need to expect the failure, because we cannot say like, okay, I'm a very good engineer, so I have set up a cluster which should not face failure. Yes, we have to expect the failure, and we have to we have to set up certain things to overcome the failure. Management tools like Cloudera Manager, Ampari, Confluent Control Center, and many others simplify the administration, which provides a single set of view for all the. Let's say you have 100 nodes of Hadoop cluster, or you have 20 nodes of Cassandra cluster, you have 50 nodes of Kafka cluster. These components can provide a single set of view. Let's say all the Hadoop, you have a Cloudera Manager or Ampari, which will provide the health of all the Hadoop components. So if you can set up an alert saying like, if this goes down, you need to send an email, or you need, the Cloudera Manager can do an alert, SOS alert. You can have a proper email which sent to the admin team that they can take care of this as high priority. And also you can see the color-based segregations of issues. Like if a particular disk is failed on a specific machine, it gives you notification. And let's say if a particular service or process is getting failed, so you would get a different notifications. Or let's say HDFS is getting full at a specific toleration you can set. So after that it will be green. After that it could come to a amber. Then it could become red. So those kind of color differentiations are there on various different things on these components. Among this component, Confluent Control Center will have slightly lesser features when compared to Cloudera and Ampari, because Confluent is bringing up a lot of features. So, but Cloudera and Ampari on Hadoop side, they are very mature. Confluent is fully on Kafka side, so the development is happening on a very good way. So they are bringing up a lot of management and the right way to manage the cluster. But that's what, on a maturity wise, that got slightly less. But again, those are two different set of companies. So Cloudera and Cloudera Manager and Ampari, they do Hadoop based. They can also manage Kafka as one of the component, but Confluent provides Kafka as for Confluent. Kafka is the only service. So like that. So we have seen about the basics of, I mean, the traditional big data architectures and what are the components involved in it, how these components are being managed, what are the ways of setting up a cluster on those things. We would also see about how these components got evolved in the modern big data era. So evolution is common. So let's say we might have started our career with as a developer of Java, then we moved to some other full stack components. So we might have learned a JavaScript, or maybe somebody who started the development career with a SQL developer or mainframe developer. So they might have moved to big data, mostly on the beginning of the career of on big data. They might have written some MapReduce code. Then they got evolved to writing Hive based queries. Then after that, they might have started using Kafka. So then enterprise like got Spark into it. They started Spark with an RDT based one, then data frame. So a lot of evolutions. When you are in a big database team, or when you are in a zeal to get into a big data career, then you have to adopt learning as a high priority component. Because in big data, if you have a specific skill today, and in within a year, the particular components maybe I would not say the components go stale, because the components will be there, but there would be a lot of advancements will be there in the component. You have to learn. So please be clear that if you are taking big data career, yes, you have to learn a lot. If you are learning as 1x now, if you are becoming a big data engineer or data scientist, then your learning should be 10x from right now, because there are huge set of components which are coming in. And yeah, the current components will have a lot of other advancement. New APIs would get introduced, new functionalities would get introduced, specifically which means those functionalities will obviously help us on making our work more simple, but we have to know how to work with that. So maybe you got a project which in which you need to migrate all your code from a specific set of ETL process to Spark based ETL process. Then you have to, yeah, and one more thing, you have to understand the traditional data architecture system, which could be either a big data or different Teradata based or Oracle based system. And from there you have to convert it. So that's what, if you want to be a big data engineer, you need to be a data engineer first. You need to understand how a normal data management works. Then you need to understand about how those can be ported to big data. And first of all, you need to understand what kind of whether you can do the same kind of model in big data, because here we have a lot of limitations. It's not transactions, it's analytical layer. So there are few limitations on the transaction. So we have to understand what are the do's and don'ts of big data. So it's not like you can move everything to big data. You have to do certain you have to follow certain protocols. So we need to do a lot of warehouse based processing or OL AP based processing. We can do it. And how the data should be stored, all of them have to be determined. So learning is one of the most important thing in the evolution of modern big data. So there are a huge number of components are coming every month, and there are a lot of advancements which are coming. There are a lot of API changes are happening. So we have to keep our eyes wide open and see all those things. So modern big data solution mainly focused on providing big data managed services using cloud and other advanced components. Let's say nowadays the companies are more towards cloud-based solution. I mean, it doesn't mean like the on-premises are not being used much. It depends upon the architectural decision and also the investments they want to move. And Spark is becoming one of the vital component, one of the most important, as I mentioned, it's becoming the hero of big data. So if you want to become a big data engineer if in your current company, you need to know Spark. If you want to get hired as a big data engineer, yes, you need to be very good in Spark. So you have to practice a lot of things in Spark. Right, I will be giving you some idea about which are the practice environments which are available for free. So you can register and take a cluster from there, and you can practice it. So you have to learn, obviously. Yeah, you have to learn from the right place. So you have to learn Spark. Then you can practice it, because first of all, learning is one of the most important thing which you have to attain, because it's not a small component. It got a lot of what I would say better architecture behind it. You have to understand everything to become a good big data engineer, because you certain easiest ways are there to work on Spark, but without the basics you cannot get into it. So Spark provides in-memory data computation, otherwise we call it as lightning speed data processing, which means the data would be taken to the RAM and there it would be processed with multiple stages, and it got integration with ingestion components like Kafka and Flink. So right now we have in Spark we have very good APIs with for structured streaming, which can integrate with Kafka. We call it as read stream API. Evolution of data frames and Spark SQL. Earlier in Spark, we were using RDD-based data object, which is purely unstructured. We have to write a Python or Scala code or Java code to extract data out of it, and then do a lot of complex codes on doing the data processing. Right now, we have data frames, which is purely based upon data frame and Spark SQL context, which are based upon SQL based, which means the developers who know data engineers who are familiar with SQL, SQL can write Spark programs. But there are a few methodologies you have to follow. So, and the next is evolution of Spark structured streaming. Consider there are a few. Let's say your company's your process your ETL is or your data processing flow is receiving let's say 20,000 data per second. Okay, so first of all, we need to get the data from the 20,000 data per second which are coming. You have to do a alerting, say like based up. Okay, if the transaction is coming from this location, or if the transaction is greater than this number, then we have to make it to a different pipeline. So we have to monitor the transaction. So it should happen on a real-time basis. So Spark structured streaming is there. Again, we know that data frames and SQL will provide SQL-like processing. So this structured streaming will help us to do proper streaming methodology again on the SQL-like processing. So we can integrate it with Kafka, and then we can have a data frame created from the Spark structured streaming, read stream API, and then we can do data processing. So it's not going to be a complex process. It's just we have to try it and do it. So the APIs are available now. You can easily integrate with Kafka. You can get the real-time data from Kafka, where Kafka, maybe in your Kafka you get 1 million data per second, or 10,000 data per second, or 50K data per second. You get it from Kafka, then do a processing and as a micro batch in Spark streaming. Then you do the it's like streaming. So you stream the data and then send results. The results could be, okay, these are the transactions which are good. Okay, these are the transactions which are greater than 1 lakh rupees. So you have to take it to a different set of process. Or these are the transactions which are from different ATMs. So those kind of segregations you can do when data are coming in. And then next is Spark MLlib. So nowadays, yes, data engineers and data scientists are keenly using Spark. They are more curious on doing things with Spark, because for the data engineers, yes, data frame and SQL, which would help them on doing a SQL like processing. And for data scientists, yes, all the models they run, like let's say large supervised learning, unsupervised learning, or whatever the deep learning libraries, all of them are available with Spark. And also we can use pandas and Spark MLlib together on a Spark program, and we can execute. Along with that, we also have graph processing methodologies. So GraphX is there, Spark GraphX. So which could help us to first of all, we have to identify what are the vertices and edges components. So based upon that, we can do the data processing. So that would, again, we can integrate the graph processing with MLlib for better processing. So Spark is having all set of components nowadays, which would help the data engineers and data scientists to attain very good elevation of their jobs, which means now with the Spark, the data would be processed in memory and also in a distributed way. So you run a machine learning algorithm, you can convert it to Spark, or you run a data existing data flow, you can convert it to Spark and get it done faster. And one more most important thing. So as I mentioned, we are going to, Spark is going to process everything on RAM. So we cannot take all the ETL on Spark. So as an architect or as a developer, we need to know, like, okay, so this process is going to deal with very huge amount of data. Then I may have to think about my infrastructure, and then I have to either choose Spark. Maybe if you have an ET of half an hour, and if those can run and MapReduce, yes, please give away to MapReduce. So it doesn't mean like you have to migrate everything to Spark. So most of the data engineers or data architects, they are highly enthusiastic towards it, and they want to move everything to Spark. Please try to maintain an equality, so that give way for all their prioritized job or streaming for on Spark. Yes, batches are also possible in Spark, provided your infrastructure is very good, and also you have a better cloud managed services or infrastructure on-premise infrastructure. So my advice for the developers is like give equal importance to run certain batch jobs on MapReduce and segregate certain streaming or micro batches or some of the high priority batches on Spark. So the next most important component which got evolved a lot and it's been again another talk of the town is Kafka. So Kafka becomes enterprise data ingestion component. So it's ingesting trillions of data. So there are a few email providers company and there are e-commerce company, companies like Uber. So they are extensively using Kafka because they are getting very huge amount of data generated every second. They wanted to do they want to derive value out of it. First of all, yeah, we have a better infrastructure, we have big data infrastructure with Spark which can process the data, but how do we ingest the data? Kafka was actually an ingestion backbone for most of the company, where we can create, we can have all the data flows through Kafka, and Kafka has now evolved with Kafka is a distributed pub-sub model. Okay, it works based upon distributed pub-sub. So in Kafka now got evolved a few components like case streams where you can do streaming with Kafka. Earlier we were just using Kafka as a pub-sub model. So now we also have ability to stream the data out of using Kafka. We also have Kafka Connect, which would help us to create there are, let's say you want to take data from RDBMS, or you want to take data from S3, Amazon S3, or you want to take data from Azure Data Lake Store. So Kafka Connect provides a predefined connector. So we just have to pass the parameters and do it. We don't have to write producer and consumer on both the sides. So Kafka Connect provides source and sink components. So you just have to pass the parameters and get it. So the next is schema registry and REST proxy. So schema registry is like you can say Kafka like receive message on this format, and you can also open a REST endpoint for Kafka using REST proxy. Other one is KSQL, where you can just take all the data. Again, it's a next level abstraction like KStream. So you can stream using structured based queries. So Kafka has evolved a lot. So that's the reason why it's been chosen as one of the enterprise data ingestion component, and it is like for you to have a like this, if you are a big data engineer, or if you have a plan to become a big data engineer with a lot of learning, yes, you have to learn Hadoop. The next is Spark is most important thing. After that, Kafka will be another leaf to your crown. So Kafka is like, when you see any of the big data engineer job descriptions, yes, Kafka would be there, because the integrations and all the processes nowadays are becoming real time. So we need to know, as a big data engineer, we have to know how to integrate various different infrastructure. It's not just by knowing Hadoop you can excel in your career. So you have to learn a lot. That's what this is, one of the component which has evolved a lot. So of course we have to learn this. The next one of the important thing which is coming is Flink. So this is again, Spark got certain limitations. Spark can do micro batch based stream, but we need streaming. We need to get the data derived within 400 milliseconds. How do we do? So that's where Flink comes. Flink provides low latency streaming engine, which is suitable for actual real-time based data processing. It provides exactly one semantics, which means Flink can ensure it can receive the data and it can process the data only once. So no duplicates and no data drops. And also it is suitable for batch, interactive, and real-time processing. It can run iterative processing based upon the machine learning iterative algorithms. It can do fixed data, and also graph processing is integrated with Flink. So nowadays, like if you are again, if you are a big data engineer and you are architect right now, and if you want to enhance your career on, or if you want to have more, I would say, like if you want to learn something very useful, then please learn Flink. So Flink is going to be one of the next level component. We have one more component called NiFi, which is there. You can also learn it. That's a data flow component. That has been used in a few other companies. But for data ingestion, yes, for real-time streaming, Flink is the and one more thing. So you may ask a question that okay, you are saying Spark streaming can do even partition, Kafka can do streaming, then Flink can do streaming. It is something like it's a different mode of transport. When you want to go to from let's say you want to travel from one city to another city, you can choose bus, or you can choose train, or you can choose flight. That depends upon the urgency. So similar way, we have a lot of different like Kafka can help us on the data ingestion of millions of data, and also it can do data streaming now. Yes, it is a competitor for Flink. Yes, when huge amount of data coming, Kafka can handle it. When you want again more low latency, then we need to go with Flink. We have to integrate Kafka with Flink. So Kafka for data ingestion and Flink for data streaming. So we have to use multiple components. So it's not, and one more advice for the big data engineer, if you want to become a big data engineer, or you are already a big data engineer, please don't choose a single component for doing everything. So because everything here we have in big data, we would be utilizing the ecosystem component. There are a lot of components. So consider Headspace would do random read and writes. HDFS Hive table cannot do that. So Kafka can ingest millions of data, but when you have streaming with Kafka, maybe latency will be more. So that's the reason why we integrate Kafka with Flink. Spark streaming can also do. The fact says that Spark streaming can do real time, but Spark streaming takes us a micro batch. So of course it would have some latency on time. So we have to choose the component based upon what kind of processes, based upon the different use cases. We cannot say this component I'm going to use for this use case. For this use case, we need to identify the component, and based upon the urgency, based upon the priority of data processing in the use case. So don't go with the component, go with the use case. So the next evolution happens with the introduction of cloud managed services. So companies like Amazon, Microsoft Azure, Google Cloud Platform, Alibaba Cloud, IBM, they are now providing big data managed services. So we will be seeing about what are the names of what are the different components available in AWS, Azure, and Google Cloud on big data. So consider if you are a big data engineer already, or you want to learn big data. Again, the next most important thing you have to do is, most of the companies are towards cloud migrations of big data. So you need to know the traditional big data architecture, and you want to know the alternatives of those on cloud. So okay, maybe there are two terms which are there are specific different names on cloud. The architecture would be slightly similar. So let's say Hadoop, like Spark, we can get the same Spark on EMR from AWS, and HD Insights on Azure, on Google Proc. So all of them provide Spark as a service. So we need to know the terms, and we have to just make our hand dirty by doing a basic POC on it, so that once it is done, once you are having a better training about it, so then it would be very easy, because you already know the architecture behind it. You just have to have an enablement training, so that those sessions would help you to get into how you can do the practice. For that, you need to know the basics of AWS and Azure, how it works, how the cloud managed services works. So on your learning, if when you're taking learning as a high priority parameter, then you have to learn these things. If you're a big data engineer with all the previous, let's say you have a very good Spark experience, you have very good Hive-based experience, you know Kafka, then you know what I would suggest is, please learn cloud-based managed services. That would help you on a I mean, help you on a better career focus. Okay, let's see about what are the cloud big data solutions. So what are the components which are there with cloud? So cloud hosting companies have a lot of big data managed services on their cloud platforms, which could benefit the enterprise. The reason enterprises are choosing cloud managed services is they don't have to invest much on on-premises machines, and also cloud managed services provides high availability, whereas in on-premises they have to set up teams to manage. Let's say they need to have a NetOps, DevOps, data center ops. They need to have a Hadoop admin, Linux admins, and 24 hours everybody should be running. But cloud provides 99.9% high availability or 100% high availability. So you can skip all those levels. Keep one cloud admin or Hadoop admin, a cloud admin, big data admin. Both of them. Some companies are keeping both the roles for a single person, so they can easily manage it. So the next is pay as you go. Cloud, you have to pay for whatever services which you are using. Next is no downtime. Cloud services companies provides all this high uptime and auto scaling based upon your workload. Nowadays, the cloud companies are providing auto scaling facilities. Let's say you are getting workload more on this particular time interval, then you would get more resources. So otherwise, the auto scale out can possible. And also they provide private cloud infrastructure. Let's say you have a secure environment, but still you want to go with cloud. You can afford a private cloud environment secure data storages are there, like row level securities are there with some of the cloud-based data storage. And it also got easy integration with other external components. So if you want to do a migration, they have a lot of tools. And if you want to integrate with external Hadoop infrastructure or external Kafka infrastructure, you have Cassandra installed on different infrastructure. Yes, you can use it. And the next is reliability and support. Cloud companies provide very good support architecture, again based upon the subscription what you have, and they provide reliability through that. So one of the leading cloud provider is Amazon. Amazon Web Services. They provide on-demand computing with various big data managed services. Like AWS provides EMR Elastic MapReduce for like EMR. In EMR we have Spark based cluster. You can take Spark managed services and Kafka also. Kinesis for PubSub based things. MSK managed service Kafka for Kafka based services. We can use Kafka managed services using MSK, and S3 and Glacier for data storage, S3 for object storage, and Glacier for data lake. And we have Athena for SQL integration with S3. Redshift is there for data storage. So these are the components which are available. When a company want to migrate the data from processing from their traditional Spark to EMR, yes, we can use it. If they want to use Kinesis, or they can use Kinesis or MSK for data ingestions. They can store the data in S3 or Glacier. Then using Athena, they can query the data from S3, and they can also companies can also use Redshift for data storage, for SQL-based data storage. So there are a lot of other managed services, but these are the prominent big data-based managed services which are available in the market. So that let's say if you are we also have a glue on AWS which can help us on flow management. So there are various other components. So you have to at least have your footprints here, so that it would be helpful for, let's say your company is projecting on Amazon based managed services. Then you have to learn about this, or you need to take up a course, or you need to take up a specific learning path to understand about this. The next is Microsoft Azure. They also provide on-demand big data cloud components and managed services. And Azure, let's say if you take same like EMR, Spark-based infrastructure and Kafka-based infrastructure are provided by HD Insights, Azure HD Insights. And for data, for a proper data flow based things, you can use Azure Data Factory for certain level ETL, and also for setting up data flow. We have Azure Blob Storage for storing the data like S3. You have Cosmos DB, which is integrated with SQL, MongoDB, which is there for uh, again low latency data processing. Azure Event Hub for Kafka-based or PubSub based data ingestions. Azure is also having data lake store called AZDL, Azure Data Lake Store. So again, if you are a company, or if you want to learn cloud-based components, or which are based upon Microsoft Azure, then you have to learn all those things. You need to know how these components works, how, let's say, what components are used for what. HD Insights for Spark and Kafka, Event Hub in place of Kafka for certain level, not like extensive like Kafka. For storing the data, you can use blob storage or Azure Data Lake Store. So all of them we have to choose. GCP. The next is GCP provides more analytics based big data managed services. Yes, they have BigQuery, which is their patent, and they provide low latency data processing using BigQuery. Again, Dataproc is there for a Spark based in processing in managed service. Data flow is there for having a proper ETL plus specific subscription. They have a PubSub. They have enterprise data catalog based component called data catalog. See, when you are again, if you want to learn, if you want to know about the GCP based managed services, yes, you have to visit all those components. So these are the components which are being used by the enterprises when they want to migrate from the traditional on-premises to the cloud-based managed services. So again, like it's again like you cannot be a pioneer on everything. So you have to choose like I would suggest like all the three have very good market shares. AWS, yes, they are leading in the cloud managed services, and Azure, yes, they are also equally coming up. GCP is picking up a lot, and there are a few companies who are using Alibaba Cloud, IBM Cloud. So it depends upon the organizational decisions like which they want to use. But again, on those managed services, yes, we have components like this for specifically for on every cloud providers. They have different components. So those components are helping them. I mean, like through those components, we can leverage the same efficiency what big data can help give us. So though I mean, as a data engineer, as a big data engineer, if you want to elevate your career to a different level, or you want to have a cloud expertise, yes, you have to visit all of them and you have to learn it. So these will provide you a better career focus. The next is need for real-time data ingestion. So why do we need real-time streaming, real-time data ingestion? Because I mean, as a consider you are booking a cab in Uber. So if Uber is not, if or maybe like you order food through Zomato or Swiggy, so we get a lot of thoughts when the food is not arriving on a particular route. So which means the locations from the delivery person has to be tracked, and it has to integrate with the mobile, and it should be within seconds. So we expect it. That's how they give comfortable scenario with with their apps, so that we can track the movement. Uber. So if you feel like the driver is not moving towards a specific direction which you have booked, maybe you don't trust Uber, so you call the customer care, you cancel the booking. So a lot of things. Again, the transactions, you did some transaction. If the OTP is not coming to you within seconds, then it's not a right way. So that's the reason. A lot of, and also you are you consider a person who is involved in more fraudulent activities, then they are booking a same kind of products in Amazon, and they, like say Amazon wants to monitor them on a real time basis. They may have to block their orders, or they may have to do certain things. So businesses are now becoming data driven, which means they have to decide based upon the data, because they uh, right now they have gathered a very huge amount of data. They want to leverage value out of data. So analytics play vital role in decision making. So they would be having specific list of customers who always cancel the ride. So then there's like they have to take some action against them, because they are wasting the resources of the driver. So I know that's what, based upon that, they have to do a lot of decision makings, because right now on this data driven scenarios, the enterprises have to take the data on a real time, and they have to derive value out of it on a real time within few seconds, so that they can do a better decision. So real time data streaming involves continuous input. The ingestion will happen on a real time. So you have to process the data on a real time basis, and then output should be sent, so that multiple business models can get benefit. So let's say you have alert mechanism which is there, which based upon the data which are coming in. Yes, the alert mechanism should work, let's say within 400 milliseconds or within 1 second. So it has to send a notification to the, or it has to send a mobile notification, or it has to send a email notification to the entity which needs to be alerted. So by that way, the trust on the business would be high. So real-time data processing and event partition helps the organization on various factors. We'll see that. So they can help the companies to have a proper fraud detection system. And in most of the countries, the traffic management systems are becoming automated. So alert systems. So there are a lot of alert mechanisms. Let's say, like if this happens, then this should be the next results based upon machine learning algorithm, or based upon a previous patterns. So the alert system will be working, and weather focused and pandemic focused. So now you guys know a lot of companies are doing COVID based pandemic focus, like okay, hotspot identifying, cluster identifying locations. All of them are happening just because we have the data. And industry component model. Let's say some of the car manufacturing companies, they would be having a lot of robots now to manufacture their certain parts. So in that scenario, we need to monitor the data which are coming from the robot, so that it should not do a malfunction. That's what automations. So a lot of automations. Let's say most of the companies are towards operational efficiency. So they want to reduce the work of the call center employees. So they want to reduce the work of few components. So in that scenario, yes, they would be setting up more automations. Let's say a company in US, they were having a set of people who were watching the, let's say they collect a specific document in PDF format, and from the document they extract the data and they send it to a team for a next set of team for processing. In that scenario, it's easy. Like we have OCR components. So using OCR, we can either build a OCR, or we can use the OCR managed services from AWS or Azure. Then all the PDF data can be captured with more accuracy, and then it can be sent for the next process. So that's an automation which may lead to a specific level of job loss. So that's what companies are now looking for. automations. Whenever, if let's say, this is my kind advice, if you are doing a work, if every day in day out, if you do the same work, then you have a high chance of getting automations, I mean, like abrupt your job process. So the automations are playing vital role, and in the automation the data plays very high priority role. Yes, with the help of real-time streaming, again, when something is happening on automated way, yes, 100% real-time streaming is happening there. We have components like big data components, Spark, we have Kafka, Flink, all of them which can help us to do the automations. So real-time ingestion using Kafka. So now we have Kafka which can take data from any infrastructure. Like we saw that Kafka Connect, which is helping us to import data from databases. We have when okay, let's say I'm getting data from Kafka Connect, and from there we have a Kafka streams. Through Kafka stream, there should be a machine learning app, or we can have a training data built on other side, and we can run a machine learning app. So by that way, on a real time itself, we can run a machine learning algorithm and get the solution out of it. So this architecture, let's say, again, on enterprise wide, you want to do a prediction within few seconds. Yes, you can get the data from, let's say your data are coming from IoT devices, or your data are coming from sensors. So all the data can be imported to Kafka. Yes, Kafka can take the data. From Kafka, you run a production machine learning model. So from the machine learning model, here you get the results out of it. Then again, yes, your model will throw the result within few seconds. Or maybe you have certain models which would run on different iterations. Let's say it could run 24 times, 25 times, or 15 times. So you can still run it. It would be a fraction of few seconds, then, or milliseconds. So then the results would be extracted and taken it for an alert system. So yes, this particular car got stuck somewhere. They got more ticket, and this car should not be. I mean, this, or maybe like consider there is a road which is having a traffic monitoring system. A specific car is going on more than 80 miles per hour. So yeah, they can monitor it on all the things, and maybe they can look up with driver's data, and they can create a ticket, and they can send it to the driver's mobile itself, or to the driver's email. So these kind of systems can be set up. Or maybe there is a electricity provider or water provider, they want to set up a IoT, and they want to understand, is there any security breach happening. Let's say uh, uh, a gas provider or electricity provider, there are some breaches which would happen. They may lose some electricity or water in between. So in between their source and the destination, which are the consumers. So there are some people who are breaching the electricity. So they can set up some people who breach the water. So they can set up a monitoring system, and they can do it. Those are happening in few of the Gulf countries. So, and also machine automation. So let's say there are a huge amount of let's say a company which is which is running oil extraction using rigs. So in rigs, they can keep a lot of automations, and they can identify the wear and tear, and based upon the wear and tear, the rigs parts can be replaced. So all of them can happen on real time. So Kafka plays a very vital role on event partitions. So we can get data from any data sources. Yeah, there are a lot of Kafka-based integration components are there. Like for IoT-based things, we have MQTT integrated with Kafka. Yes, we have MineIFI integrated with Kafka, and a lot of other components are there which can be installed along with the IoT agents are having integration with Kafka. So they can take data on a real-time basis, and we can do anything after that. So the next is about Flink. Flink is also having a real-time pipeline. It can take any transaction log data from IoT or web clicks or from database system. The real-time event can be captured, and it will be taken to the real-time distributed Flink environment. We can do event-driven applications. Let's say if this happened, this should be the case. That's how the event-driven application happens. Event partitions. Okay, so consider from on a particular from a bank from a customer side. Okay, he's doing a credit card transaction. That's a separate set of event which should go to the credit card LOB, and they're doing a specific payment for a loan, or the customer is doing a specific uh, ATM-based transaction. So all the data should be captured, and then it should be taken to a different event-based engines. And then for streaming, yes, alert mechanism will run on stream and batch and the stream analytics. So then once that is done, based upon the process, the data can be sent to any other space. So the thing can take any real-time data, which could be from a transaction-based systems or loggers, IoT, web clicks. We can take the data from tower data from on the telecommunications. So everything can be taken to the Flink, and it can do a streaming and send the data. So we have nowadays infrastructures which can Using Flink, again, we can do very low latency data processing. So this is one of the common architecture which is being used in most of the companies. So the next micro batch event streaming using Kafka and streaming. When I say Kafka and Spark streaming, I said another word, micro batch. Yes, it is micro batch based data. The data which are capturing from Kafka will be sent to Spark streaming. It could be Spark dstream or read stream. There are two APIs. Both of them have ability to micro batch and microbatch plus real time. Yes, Spark nowadays, Databricks, we will see about Databricks. Databricks provides slightly more low latency processing. Yes, it's based upon it. So from the Spark, we can write the data to S3 or Hadoop, HBase, MongoDB, anything, and then it can be sent for any different processing. So uh, for very low latency processing, we can use Flink, and for a huge amount of data with another set of stream, we can use Kafka. We can also use Spark and Kafka streaming for micro batch based processing. So the facilities are there. We have to choose which one for what use case. The next is advancements in big data. So when we say advancement in big data, okay. So earlier what we were doing, so we load the data to HDFS or we load the data to Kafka. Then from Kafka, the data should be taken. Okay, Kafka loads the data to Hive table or any location in HDFS. From there, we have to write a program, a MapReduce or Spar program, which could take the data with an RDD or data frame. Then from there, we do a pipeline. Again, we have to write a lot of pipelines in the code. So first is the one set of pipeline, the next other set of pipeline, then we have to do it. So integration would actually become slightly challenging. A lot of pieces of code will be there, and like the code should be running on a different set of time, and it should be lined up properly. The integration should be properly done. But in the modern era, we have few big data based managed services companies, managed services products which are there. They are helping us to improve the development. I mean, the development time and also efficiency of the code. So integrated big data solution, there are few, provides easy code development and execution platforms. The job scheduling becomes more easy. The job integrations becomes more easy, and also auto scaling of the cluster. Let's say again the same scenario during this time between this schedules. Let's say every night 1 a.m. to 4 a.m. there are more jobs which would be running. During daytime there would be less business, or maybe if it is a say e-commerce based business, there are some times like during Black Friday you get a very huge amount of transactions, or during big billion day sales you would be having very huge amount of transactions. So in that scenario, for those specific time window, we need to take more resources, so which would help us to satisfy all the customer needs. So auto scaling is most important. Then integration with other components. Yeah, existing component, big architecture, which could be anything, big data or any other. There would be a lot of other components. So this advanced component can have to integrate with it and make use of it. Then ASIC transaction-based data storage. Yes, transaction-based data storage, because most of the big data components are OLTP based. So we need to think like if someone provides OLTP, so how that can be effectively used and for what purpose we can use it, and integration with the other public cloud. So how it can sit over the existing AWS or Azure public cloud and help it. That's what we are going to see. The first one is Databricks. So Databricks provides Spark as a cloud managed services. So Databricks available with AWS and Azure. So they can use the Azure and AWS machines for running Databricks infrastructure. Databricks provides community cloud for the developers to practice. You can go to community.cloud.databricks.com. So you can register your using your company work email ID, and you can pull a community free cluster, 15.3 GB RAM based and 1 DBU based cluster will be provided. So you can you do a basic practice there. Then in that particular environment, notebook will be integrated. So for code development and execution, the data scientists or data engineers who are familiar with notebook, you feel a native environment there. So you can write queries based on Python. You can do a data processing based on Python, R, Scala, SQL in Databricks. Java is not available for your information. So they will in Databricks, Python, R, Scala, SQL based executions are possible. And cluster management, yes, it's very easy. The Azure admin can easily handle the cluster management, and they have a job scheduler. They have a cluster manager which would actually help us on analyzing the cluster usage and help us a report saying like what this time the cluster should be. We have to scale it down, or based upon that we can take a decision. So Databricks, and also let's say you have a Databricks cluster, it's very easy to add the external jars, may Spark and general Maven files, Python egg files, or other libraries. We can just easily add it in the cluster using few clicks, and it provides time for job scheduling and monitoring the jobs. And data, the one of the most important thing which is coming up in Databricks is Delta Lake. So Delta Lake provides asset-based data storage, it supports transactions. That is one of the most important thing. So using Delta Lakes, we can do change integrations, CI/CD, SCD-based procedures, and like most of all the data warehouse logics and the transaction-based logics are being applied with Delta Lake. So you can go through what is the Delta Lake and Databricks. So that will help us on understanding why do we need to use Delta Lake and what are the facilities which are there, why, how it is efficient on handling the queries. So again, Databricks is highly suitable for Spark structured streaming and real-time machine learning flows. Databricks provides ML flow, which is another budding infrastructure from them. So using Databricks ML flow, so you can write and schedule the data machine learning program in a very ease of development environment. So this is how the Databricks infrastructure looks like. So you can easily write a PySpark or Scala-based program or SQL-based things. You have you can explore the data option here and go to the Delta Lake tables, and you can go to the cluster. Let's say multiple clusters are there, and you have a job. Let's say you want to see the schedules and the runs of the jobs, like what happened in the previous run, or is there any delays or something like that. And you can run this particular notebook using here, or you can publish a notebook and put it in a Git or integrate it with the different infrastructure. So you can attach and detach the cluster. A lot of things are there. It's very easy. Like you can see that, right? So you write a code and you can run it. So you must be knowing how to code. That's it. So all the other management, running the cluster, running the code in the cluster, adding the libraries, all of them are integrated properly so that the things are working on a very easiest way. The next is Cloudera is also providing few managed services on AWS and Azure. So to set up industry standard Hadoop cluster on cloud within few minutes. So Cloudera provides CDF, which got NiFi and Fling Pack. They have packages which are there, and like CDF separate package, which is helping companies to have only data flow and data ingestion based component. They also provide data science workbench, which is integrated with all the machine learning libraries, and which would help the data scientists to run that model and experiment it. They can easily just by click again, like notebook, they have a different environment, not a notebook environment. So in that environment, machine learning programs, all the libraries are integrated with the existing Hadoop cluster, and this Cloud Data Science Workbench will help them to run the program. So it again, it provides a very easy integration with the existing Spar cluster, and so the data scientist can just focus only on the logic, running, executing it, productionalizing it. They can just do it with few steps. That is the, and also uh, like they have all the libraries using Spark MLlib, all the libraries which they use. Pandas are available there. So the data science library can work with Python and R. In R, it's Spark layer based. Python is PySpark based. So they both are available in the data science workbench. So this is how Cloud that's the data science workbench looks. So how many sessions are running? What are the jobs? What kind of CPUs are there? How much RAM is getting occupied right now? So the developers have to write the code, and they can see the execution on the left and the right side. So they can create multiple projects. So there are a few other things which are added right now called experiments, models, creating models and creating an experiment. This is slightly older screenshot. So in 1.6, they have added experiments and model-based tabs, which are like you can run some experiments on a model which you have created. So the cluster metadata, how the cluster is running, job, is it more highly occupied now? All of them can be seen, so that they don't have to go back to different screens or different utilities to monitor the jobs if something is not running. So everything are integrated in a single area, and this is how the big data era is moving. So now we are having few services and we are having few products which are showing us everything based upon the job. Let's say you run a single job, so you have the Spark UI will be integrated, the Spark history server will be integrated if the job finishes, and also the utilization reports will be there, and the results will be shown in a proper structured way. The Databricks and CDSWB, so they have everything integrated in a proper way. So with those features, we as a developer or we as data engineers can easily write a query, we can monitor the job, and we can get the results within a single environment. So these advancements are helping the data engineers and the data scientists, or the like say if you are a fresher and you want to become a big data engineer, right now with all those advancements, you have to learn a proper course or proper flow to understand all of them, and working is it's pretty very easy. So it's not going to be a complex environment. The managed services or the services are making everything more simple. So it's like we have to know the data logic. We have to. That's what the companies like Databricks and the companies like Cloudera, they are bringing up the things to make again the cloud managed services. So the developers will focus only on the logic. All the other external factors they can just like skip it. All of them are integrated. So even if they want to run the program, just run it. They don't have to say which cluster it has to run on. So cluster would be embedded, and you can run it on the cluster, or you can detach it and add it in a different cluster. So it's all by few clicks. And you want to see the job execution, you don't have to go to a resource manager, or you don't have to go to a specific job history server. Everything are integrated. You can just click the job related flow, and then you can see it. So all of them are available right now. So these are the various advancements which are there in the big data market, which is helping on a lot of other factors. So what I would suggest you is, if you are if you are a beginner on big data, please learn about Hadoop and Spark. Yes, that is most important thing. And then you have to know about I mean Hadoop and the Spark, and this all the Hadoop ecosystem in Spark. Then you need to know about how Hadoop works on cloud managed services. Then again, you have to know about how you can execute those jobs in Databricks environment. And I would also suggest you to learn Kafka, which is one of the most important things in the job market of big data engineers. Then you need to know about any one of the NoSQL component like Cassandra, MongoDB, or I would say Cassandra or HBase or cloud-based managed services. Again, you need to know any one of the cloud-based things. It is necessary to have AWS, Azure, or GCP-based knowledge. So I mean, whatever I'm saying, you go and take a job description of a specific companies, you would see it, because nowadays companies want us to be a person who knows everything. So at least you guys have to know how to do this. So please keep learning as a high priority, and on those learning plate, please keep all those components. So you have to eventually learn it, or else the job market or the career enhancement will force you to do it. I'm handing over the session to Praxi.
Okay. Thank you so much, Navneet.
Prerna.
Yes, I hope I'm audible to everyone.
Yes, Prerna, you're audible.
Great. So Navneeta, thank you so much for conducting the session. I could clearly make out that you tried sharing all the experiences in so much of less time, and as much as you could have done. I think it has been done really well. So thank you so much on behalf of all the attendees. So to my participants, I'll just want to mention that the times are tough, and we are really encouraging a lot of virtual sessions in different forms. Either it could be a webinar, or say masterclass, or full-fledged trainings that we do, or these could be boot camps that we are trying to run for everyone. There are lot many benefits of doing trainings on a virtual platform, and we are trying to get to more and more people basis the same platform. So yes, in case you need to know more about Apache Spark or Big Data and any other technology, please leave us a note after in the survey form, and please share us the feedback as well about how you felt about the session and whether you would be interested in taking up the training on this or not. And we will certainly be coming back to you with a response and a solution. So yes, we'll be looking forward to your feedbacks, and hoping to serve you more and help you more build up better careers and skill sets with your in your own areas. So thank you so much one more time, and I wish you guys all the best. Please take care, stay safe, stay indoors, and let's obey the lockdown that we are into. Thank you so much.